Okay, I'm going to, today, being the first speaker, trying to set off the challenge and the learning opportunity for you for the compost bedded dairy pack barn. And one of my first challenges is how does it fit in with the system of animal waste management, particularly on the dairy farms. But I want to give you a little history about how I got started in it. One day, the next speaker, Jeff Bewley, came to my office door and said, "Do you know anything about a compost bedded pack barn?" I said, "No." And he says, "What do you think about cows being raised and housed on compost bedding?" I said, my first reaction was negative. But Jeff had invited me out to visit several of the farms that we had in Kentucky. And this is about 4 years ago. And my reaction after visiting them was a lot different because I saw a lot of positive aspects of these particular compost barns that fit in, particularly in Kentucky for small dairies and some of the environmental challenges that we do have. As I said, I'm an extension professor at University of Kentucky in Ag Engineering. And this has been one of my focus areas, as I've said, for the last few years. One aspect of what I'm talking about today still is that our focus is still on the cow, being a cow-centered management. And how does this system fit in with how we focus on the cow and how it's focused for it being a productive unit on that dairy farm? Each dairyman does have a significant challenge. You know, the cost of production that you have to face every day in terms of the feed, energy, capital, and bedding. And particularly those latter two, I think, become important in terms of this compost barn in meeting some of those challenges. How do you maximize your cow productivity? The big challenge in so many of the cases are the environmental issues that you have, water quality. Particularly on a lot of the dairies we work with, a lot of them have high phosphorus in their soils from years of putting down waste on their fields, and they're in watersheds or near streams that phosphorus ends up, in terms of the water agency, want them to move out of their farm, not put them on those fields next to the dairy or near those streams. And some of the challenges with air quality that we have. But also as part of this system is looking at the animal welfare issues that you have a challenge with, the quality of life of those animals and their health. It's such an important part of cow-centered management. And still another particular important issue is the quality of that milk that you're selling, the value of it to the consumer. All the challenges that you are confronting. In Kentucky, dairy facilities are a significant source of water pollution. And when I was talking to the associate director of our division of water in Kentucky, he looked at the compost bedded barn as a particular practice that can improve many of the issues that he sees that are challenging on dairy farms, particularly our small ones. When we look at waste management, it still has to fit into a total system. We have to account for all the waste on our enterprise throughout the year, and it is a management of all the waste, all the time, and all the way. It is part of a total management. This is still, again, periphery to looking at and managing that cow. You know, in terms of fitting in what is the best system for you, there are several questions that you really have to deal with. Your personal preferences, what's your available labor, capital, and looking at the cropping system and looking at where we're putting that waste is the soil types, cropping practices, how much manure are you producing, how many animals do you have, and the applicable regulations in your state, particularly in here in Ohio, which I'm not that familiar with. But some of the challenges that we run into in terms of the division of water is looking at particularly with liquid systems, overflowing. They're not having adequate storage. improper design at the beginning. Our fields are wet. In the springtime, sometimes around these facilities with mud, we really can't get to them and empty them. What are some of those challenges? In dealing with that dairy farm, we also have discharge from our silage, liquid waste from that. And it gets into our streams. We've had significant issues in Kentucky in several cases where this was a point discharge from our dairies that we still have to deal with. Looking at the discharge from our parlors, in terms of that discharge getting into surface waters. We also have the feedlot runoff, unguttered roofs, water that we have to deal with, also in high use areas around that dairy. From manure storage, here we have an uncovered storage, but one of the options is looking at a roof storage. We also have to deal with the challenge of sprinklers and cooling our cows during for heat stress. How do we deal with that runoff? It's another part of waste management. So if we look at a dairy and we look at all these sources, in this particular case, we have a dairy with a semi-solid manure from our housing. We also have that manure that's coming from our parlor and our holding area and our young stock housing. We have the liquid parlor waste, as well as our runoff and leachate from our silage. In this particular case, this system is centered, and a liquid system works well for it. In some dairies, it's not as easy to put a system together like that for a liquid system. We have here in this particular case, we're having a distance from silage. We have solid waste storage on here that is still some distance that we have to deal with. Here we have a simpler system in which everything is close together and our liquid waste system works. But the challenges with liquid waste systems, depending on the geology, soils, and local requirements, we may have the less expensive earthen structure, but like in Kentucky, the requirements for lining of that earthen structure or a concrete structure that's there on the left may be required to store those liquids. But one of the challenges with a liquid system, if we look at bedding for dairy cows, sawdust or straw may work well with a liquid system, but if we go to what is considered a gold standard for pre-stall housing, sand, we end up with a challenge of dealing with that sand and how it impacts equipment. For small dairies, it is difficult to deal with, a lot more expensive to deal with those with sand bedding. In managing those storage structures, in terms of maintaining their integrity, becomes important. But really, the challenges that we have with liquid systems is disposal of it. Odor issues, in terms of tank discharge, putting it on frozen ground, heavy irrigation on the right. In many cases in Kentucky, where a lot of the problems occur is not managing that irrigation system well, and we have runoff into our streams, and we've had fish kills from them. In terms of liquid systems, we have the issue in terms of maintaining good residue if we're trying to do injection in terms of our coverage because of the many highly erodible soils that we do have in Kentucky. And it is a challenge with them. And even with these kind of systems, if you don't manage them well, we may have excess application and we have runoff. But when we look at a liquid system, one of the big challenges still is try to maintain nitrogen integrity. We lose nitrogen as ammonia. We can lose nitrogen in terms of denitrification. And so in a liquid system, we may end up having significant losses of nitrogen. How concentrated is that nutrient? In liquid systems, we're moving a lot of water. And if we look here on this chart of concentration, particularly of nitrogen, if we look here, and particularly with nitrogen on it, in our scraped stack pad and scrape manure. Is that it? Okay, good. Thank you. We have about 9 or 10 pounds of nitrogen per ton of manure as is moved. When we look down here on liquid, high solids liquid manure, we have around 22 pounds per 1,000 gallons, or around 4 tons of liquid. So when we look at that, we're moving around 5 pounds of nitrogen per ton of waste. If we go down here, even with anaerobic lagoons, 15 pounds of nitrogen per 1,000 gallons, or about 3 to 4 pounds of nitrogen per ton of waste. But if we look up here on the compost bedded barn and looking at some of the averages of nutrients, we find up here as high as 21 pounds of nitrogen per ton of bedded material, which is around twice as much as what we've seen with the scrape lot. So what we're seeing here, and then in particular with the compost bedded barn, is we are concentrating nitrogen. And particularly if we have to move this material to far fields, we end up, in terms of weight, we are moving a lot more nitrogen and other nutrients per ton. Now, one of the things that I like to compare, and one of the challenges that we've had in terms of dealing with waste, is so many of the fields around our dairies are high in phosphorus, in terms of how do we deal with it. And one of the things of looking at it in terms of managing of the waste is what is the ratio of N, P, and K relative to the need of a crop. If we look at if we look at a corn crop in terms of the ratio of N, P, and K that's required, the ratio relative to phosphorus is around 12 to 1 of nitrogen to phosphorus, and potassium around 3 to 1. But even with fresh waste, if we're trying to meet a nitrogen need, we're putting down around twice as much phosphorus as needed. If we look at a stack pad, we're putting down maybe, if we're trying to meet the nitrogen need, around 3 times the amount of phosphorus. If we're dealing with lagoon and trying to meet it, 10 times the amount of phosphorus that's needed. But if we look at the compost bed, the ratio of N, P, and K are approximately what's needed for a corn crop. So in terms of disposing of that particular material, we're close to the requirements of what, in terms of the ratio of what we need for a corn crop. So this material, in terms of managing for phosphorus and trying to meet phosphorus needs, may end up, at least in terms of crop nutrients, ends up being much more valuable material. But also with compost, we're not going to be, if we need to move it off site, we don't have as much water to deal with in terms of moving this material off site. One thing too, on dealing with a compost barn, one thing that we may eliminate if converting it is, on this particular dairy, this has a housing and it has a covered stack pad. But when we go to a compost barn, that's a bit of capital investment that we may not need in terms of that dairy farm. It's less investment in terms of the compost. So now I just sort of want to start in looking at what is the compost bedded pack barn, what's involved in it. And the rest of the day you're going to hear other speakers fill in some of the details of what I'm going to introduce to you now. Compost bedded housing barn and the solid composted waste is an important alternative management practice to allow flexibility. It can be added on to an existing farm or with a new one. And it improves in terms of environmental issues. It reduces odors because it is an aerobic system in composting. We would get reduced fly population, and we have just better flexibility in dealing with nutrients. When we look at the dairy system, at least in Kentucky, we have a lot of non-confinement dairies, and some of the challenges that they are with our weather system and some of the mastitis issues of pasture grazing. The free stalls, confinement on a bedded pack that's in which we're putting loose straw bale to maintain that dry surface for the cow, as compared to the loose housing compost bedded packyard. The general layout of these particular facilities are typical of what we see in freestalls, but our management, or at least our design on them that we feel that's recommended is that we have a bedded pack area here that is around 100 square foot per cow. And that these cows have easy access to the feed alley, to waters from the feed alley and not from the bedded pack, and that they have free access and movement throughout that barn. Just another alternate arrangement of the waters a little bit away from the access alleyways. But it becomes important that the cows have close access to water and feed and be able to have access to the resting area. The history of the compost barn is that it was first introduced back in Virginia in about the 1980s by producers. So this is a producer-based system in terms of its initiation and applied to the dairy. In Kentucky, the first barn was built in 2002. When I talk to people in Kentucky and Monroe County, which is sort of south central Kentucky. In 2008, when we began looking at the barns in Kentucky with Jeff Bewley, we had found that there were around 30 barns in Kentucky at that time. And we started in September of 2010 to try and visit every compost barn in the state, to try and understand the management, try to understand what are the features of design that makes these particular beds successful. By the end of the time that we were looking at these barns in February 2011, we had found that there were 60 barns in Kentucky. This becomes a significant part of our dairy farms in Kentucky. We have around, 900, Jeff? 800 dairies. And then today, we find that there are around 80 of them in the state. So about 10% of our barns in the state of Kentucky are these compost bedded barns. And they are the dominant housing structure that is built in Kentucky in terms of new construction. So the challenge for us, when Jeff and I were looking at this, is to try and stay ahead of the issue in Kentucky and how to manage them, and so that our dairymen can be successful. Now, this picture I put up there, when I first saw it, I thought this was a dead cow. But this cow's in deep sleep. Is this good or bad? It's one of the research areas that I think that we need to understand is how does rest really affect these animals in terms of their productivity and health. Another issue on another compost barn, this was on the hottest day this year. And as you can see, the cows are bunching under the fans. That again is another challenge of design and management of these barns, because we really need those cows to be distributed throughout the barn more evenly for their waste, so that all that compost area is effective. You know, is it good or bad? No, it isn't, in a sense that the waste is concentrated in areas. And we really want to see the cows distributed throughout the barn. And how that barn is designed, how we manage it, can affect that distribution. And it becomes extremely important, because we've seen some of the issues when cows do stay in certain parts of the barn to where they become more difficult to maintain the composting activity of the bed. What are some of the benefits? And I know Jeff is going to get back into them, and maybe at times we need to repeat them several times. But I just want to go over some of the list of the ones that we had found. Improved cow comfort, lower somatic cell count, less clinical mastitis. We found increased milk production, reduced lameness, improved hoof health, less hairy warts maybe, and Jeff may address that. Increased cow longer that you can keep things. Reduced culling rates, improved heat detection, reduced odor, fly population. And I think in terms of the dairy that I've been working with closely on a project, consumer acceptance, because they want to have their farm as a tour site for tourism, for ag tourism in the state of Kentucky. Liabilities. One of the biggest challenges Jeff and I have when we're trying to get funding to understand them is still a lot of people think that these are sites of breeding of mastitis. A significant issue that having cows laying on compost and manure. It is still a challenge in terms of convincing people. And I think Jeff will have the opportunity to show you some of the positive benefits of these barns. The other challenge is availability of sawdust. That is one of the challenges, particularly as we get more of these dairies in Kentucky. Availability, timeliness, particular supply. Coming into the winter right now, it's going to be a challenge in Kentucky. Compost is, you produce heat. How does it affect the cows in the barns under heat stress conditions, laying on something hot? During this summer, when I was looking at the barn that I've been following very carefully, spending several hours out there on a day that was near 100 degrees, I was tired. So I sat down on what I found as the hottest spot in the barn when I was measuring temperature deep into the compost bed, and it was a comfortable spot. I did not get a hot seat. And cows, under some conditions, end up choosing the barn over the pasture. The other issue is really for the producer having a poor understanding of the management of the barn and the bed. And if the bed fails, it can have significant costs. But for you to manage these beds, you have to be on top of the issue. You have to understand what you're measuring. You have to have an understanding of the moisture content and the temperature of that bed and manage it before it becomes a problem. I'm not going to get into a lot of the detail of composting, but if we go back into, which you'll hear later today, but when we look at composting, that manure and straw, we're putting in carbon, nitrogen, inorganics, water, and microorganisms. We're adding oxygen by stirring that bed. And we produce water, heat, CO2, but also we produce ammonia, and we produce nitrous oxide. And in terms of greenhouse gases, that's an important issue. But as the end result, we got stable organic matter, not quite stable, it still has to be finished if you want to use it, inorganics and microorganisms, just like any composting process. In terms of the dynamics, if you look at this chart, when we do sort of windrow composting or static pile composting, it goes through a temperature cycle. Reaches a peak, falls off as it cures. But in a compost barn, we're continuously adding feces, urine, bedding throughout the period of time. And what our goal is to really achieve some type of a stable temperature of that bed. In terms of stirring, as you do with a windrow, in a compost barn you can use a rototiller that's here on the left, tillage tools. This bed, to aerate it, needs to be stirred at least twice a day, maybe even 3 times a day as some of our producers. The rototiller, we get about 6 to 8 inches of depth of tillage, as compared to potentially with a tillage tool we can get down to 10 to 12 inches. Through the time of looking at all the barns that we've had in the state, the best compromise is having both a rototiller and deep tillage, particularly where they may alternate on a day, one in the morning, tillage in the afternoon, or a couple times a week of doing deep tillage. And particularly the issue is to get oxygen as deep as possible, particularly coming into the winter time, to have an active bed that has a lot of depth, that's active. And this issue of 2 times a day religiously, this should become part of your religion if you have a compost barn. Because we found that people who did not till that much did have significant problems with them. When we look at the compost bed, we have an upper tillage layer, and depending on the conditions, we may have chunks of manure in there. We have a transition zone, sort of that's aerobic, anaerobic, and in depth it's anaerobic. And the temperature profile moves from near ambient on the surface to where the maximum temperature is right at the bottom of the tillage layer in the transition zone. And when I go out and measure temperature and look at the health of the bed, I try and look at near the bottom of the tillage zone and see what the temperature is. In terms of moisture control, and this is the significant issue that we found, moisture is more the controller of the temperature than temperature. You have to have a good handle on that moisture maintenance in terms of adding bedding, stirring, ventilation of that barn. That biological activity is generating the heat that helps dry it out, this extra heat. Bedding cannot absorb all the water and urine and manure without evaporation of water. This is particularly true in the wintertime. Air doesn't hold as much water. During the summer and the warmer times of the year, we can about match the amount of water that's put in by the cow with what can be evaporated. If you don't want to add bedding, you need a larger area so that you get more area of evaporation. When Jeff was visiting with people in Europe and kind of communicating with people in Israel, they don't add bedding. But what they have is nearly twice the amount of area per cow. Instead of 100 square foot per cow, maybe 200 square foot per cow in a covered barn. And when we were talking the economics, and if bedding becomes expensive, maybe economic-wise we want to go to a larger area, but that's a question that we haven't answered. Too wet of a bedded pack reduces aeration, it slows the biological activity, slows heat generation and water evaporation. So what we learned is manage the moisture. And it's going back to the technique, instead of using something in an oven, is going out there and use the squeeze test for moisture. In terms of the squeeze test, it's like with silage. If you can get water coming out of that or forming a tight ball, it's too wet. It's above 60 to 65% moisture. If it's a loose ball that sort of falls apart, you've got a good moisture. And if you couple that with measuring temperature, you have the management technique of that bed. That's just on drying. This is sort of the point that I want to get to that the rest of the day that we're going to talk about. The issue, particularly in the wintertime where we see failures occur, is the fact of how managing the heat losses in that barn and from this compost bed that we have here on the bottom. If we compare that to a windrow, and we know in the winter conditions that we can compost in the winter. Compost pile generally has a low surface to volume ratio. So in other words, it reduces the surface area to lose heat. But when we get to a compost bed, we got a shallow depth and a lot of surface area. So we have a high potential for heat loss. And so how we build that structure around that bed has an impact on how we manage it and the heat losses. You know, when we start looking at most of the heat loss from evaporation and convection, and that circulation and air movement over the bed is how we lose that heat. And in the wintertime with cold air, we can have significant losses of heat. So it becomes important that we have a good working compost bed to generate the heat, but also we need to deal with losses in terms of how much air movement we have in that barn. That ridge vent still becomes even more important when we want to lose moisture and heat, both even in the wintertime and even on those calm days in the summertime. Good ridge vent to let out that heat. When we were in barns that did not have a good ridge ventilation, we can just feel the heat building up in it. Because besides the cows, we've got that bed that's generating heat and moisture. We have losses to the soil. We can even have radiation losses, particularly around the edges of the barn. to the atmosphere in the wintertime. That's just a summary, I think, just about right, of the compost barn to introduce